We're on to learning target number 5 now, and this is probably the most challenging learning target based on what I'm seeing from you guys in terms of the quizzes we've done, the work we've done. It's not easy to predict. In general, these learning targets, I would say, kind of increase. You need to have one before the other in general. But this is certainly the case for prediction. You definitely need to understand learning target number 4 before predicting, because if you're having trouble identifying those reactions, it's going to be really hard to predict the products when I tell you what that reaction is. So my suggestion before you look at learning target 5 is to really nail down the other learning targets before it, and I think you'll start to have more success with 5. So for learning target 5, we are predicting, and we have really two things we're trying to predict here. One has to do with the activity of metals, and the other has to do with predicting the products given a type of reaction. And of course, we could really expand this to other things as well, but like other things, at some point we've got to kind of draw the line and say, okay, physical science, this is enough. And if you enjoy it and you want to see more of it, then by all means take chemistry, and that will pick up where we've left off, and you'll see more of this stuff. But um, let's start with the activity of metals, and I'll do my best. One of the things that is difficult is that since this is only my second time teaching physical science, I have very few ways of explaining things, and sometimes, as some of you have probably felt or said, I may say something and it's not a good enough explanation for you, and that's where I'm really hoping you guys will talk to each other, because the more you talk to your fellow classmates, there's a chance that somebody in class has a way of explaining it in a way that's going to make more sense, because your fellow classmates talk more like you do. So, I've seen that before in math and in science. So, really try to get out of your bubble, so to speak, of the students you typically work with. Go talk with other students in the class, and especially if you're having trouble, see what they have to say. And you might be surprised that somebody's explanation clicks. So let's look at the activity metals. We're actually going to switch to this, and we're going to look at this chart here. And the nice thing about this chart is that this actually contains the metals that you guys worked with in that first lab. So in that first lab, I'll just refresh your memory. You guys had 6 metals. Magnesium was one, and then these other 5 after it: aluminum, zinc, iron, tin, and lead. You had all those 6 metals, and you placed a little bit of each of these metals in a test tube with copper sulfate, and then you were to kind of observe for about 10 or 15 minutes and see what happens. So, as I said before, there were some issues with this. One thing that Mr. Baker and I both realized was that aluminum, many of you said, did not react. And I could see, as I kind of walked around and looked at what you guys are doing, sure enough, nothing was happening with aluminum. And you can see on this chart that it should have been the second most reactive. I think everybody did see that magnesium, the first one on this list of those 6, magnesium did react right away. So many people saw that, but again, aluminum, nothing happened. So you might think that it's not reactive, but in reality it is. So there were some issues there with aluminum. There were also some issues, and one of those was, now that you've learned about the factors, is that we had some different shapes for each of these. Magnesium and aluminum, we had little rectangles that I cut off of ribbon. Zinc was kind of this gnarly looking, I don't know, almost looks like a little meteorite or something. It's just kind of twisted and has different pockets in it, and it's just really gnarly looking. So the bottom line is that for each of these metals we had different amounts of surface area. So if you think about the factors that we're talking about now, Well, we want to try to control everything. If we're going to really look at how the difference between how these six metals react, we want to try to control as much as possible. And sometimes, based on what we're trying to do, we're going to kind of draw the line and say, okay, it's not worth, for example, trying to measure the exact masses of all these, because ideally you'd want the exact same mass for all six of these, but that's going to be very time consuming. But something that is not as time consuming is trying to get the same surface areas for all these. So, for example, if we used a rectangle piece of magnesium cut from a ribbon, well, let's take a rectangle piece of these that are also cut from a ribbon. That way we're comparing apples to apples. So I just mentioned that, because you guys did see some things that were supposed to happen in that lab, and there's some things that you probably did not expect or predict correctly, because just based on the setup of the experiment. So that, which obviously was not your fault. So anyway, if we were to redo this lab, you might actually rank these according to how you see them on here, because you would hopefully see that magnesium reacts right away again. And lead does take time, so lead, because it's on the bottom, you'll notice if you look at this arrow here, toward the top is very reactive, toward the bottom is unreactive. So in this list of six here, magnesium is going to be the most reactive and lead's going to be the least reactive. So, you guys did that lab, you observed for 10 or 15 minutes. You would probably need a longer amount of time to see lead react. But we know that lead does react. It even reacts with water. So if you think about history, and we don't even have to go back to Roman times. We can go back to history here in America. But they used to do plumbing with lead. So every now and then, my wife watches the home improvement shows, and they'll renovate an old home, and in that old home they might have some lead piping. Well, they replace that lead piping now because they know that even though it's probably cheaper to use lead, it's also more harmful because lead will react more than copper, for example. So over time, lead is going to react with water, and you might drink a little bit of that lead. And of course, after a while, years and years, that's not a good thing. But copper, not as bad and not as reactive. So that's why they use copper in plumbing a lot versus lead. So anyway, what I want to say is just how to read this, because I think a lot of people are having trouble with that, and hopefully my explanation works. But we did look at several examples of single replacement reactions or single displacement reactions where we had two different metals. And a lot of times one of those metals is actually in a compound. So sometimes you'll have a pure metal. So for example, you might have aluminum, like aluminum foil, and then you'll have a compound like iron oxide. So this is the example you guys saw with the two iron spheres. One iron sphere was just the iron sphere with rust on it. The other iron sphere we wrapped with aluminum foil. So when you collide those with enough energy, you can actually get a single displacement reaction. You can actually cause the oxygen, which is in the iron oxide, to switch from iron to aluminum. So when you guys do that and you see that, you hear that sound, you see those sparks, you got that reaction to go. You actually had the oxygen from iron oxide switch from iron to aluminum and form aluminum oxide. And at the same time, the iron oxide is forming pure iron. So it's kind of cool that you can actually do something like that. Actually change something into a pure metal. But that's what we're looking at here, is we're looking at two metals. And the way to read this is, if the solid metal is on top and the compound is on the bottom, a reaction will happen. So look at that same example again. We have solid aluminum in the aluminum foil, and we have iron oxide. That's our metal compound. So a reaction is going to happen if, of course, we provide the activation energy needed. But if you switch that around, if you look at the opposite of that, which is basically our two products for that reaction. If you look at solid iron and aluminum oxide, notice now that the solid metal is on the bottom, a reaction will not happen. So that's how you read this again. If of the two metals you have, one being solid, one being the oxide, if the solid metal's on top, the reaction will happen, given the activation energy, of course. But if you have the opposite situation, there's going to be no reaction. So again, there's a lot of things to look at here. This also, you can look at that interactive periodic table again and look at the elements that were known back in ancient times. And those metals, those elements that were known in ancient times are on the bottom of this list. If you look at ancient Egypt, ancient Rome, example, on, ancient China, they knew about gold back then because gold does not react very well. So you can find gold in its pure form. But if you look at the interactive table again, these elements at the top, these were discovered much later because they already have reacted with things, and you're not likely to find calcium in its pure elemental form. It's just already reacted. So you notice it reacts with water, it reacts with air, it reacts with acid, and so on. So not likely to find it. But anyway, hopefully, by stating that again, it's helped. I'll just say it one more time. You've got a reaction between two metals, one solid, one within a compound. If the solid metal is above the other metal that's in a compound, the reaction will happen. If you have the opposite of that, where you have the solid metal on the bottom, for example, if you had pure gold and you had potassium nitrate, and you put those two things together, nothing's going to happen. The gold's just going to sit in the potassium nitrate, and they'll sit like that forever. So anyway, I'm going to stop on that one. I'm actually going to do this learning target in two parts because I wanted to make sure that people understood this chart, hopefully. So I'll do the learning target 5 a second time with predicting the products. But again, that kind of goes back to knowing the previous targets. So let's get out of here. Maybe I do have time after all, because we really, it's just a matter of doing practice. So what I'd say is go to ChemFiesta again, go down to, notice that we have M types of reactions, that's learning target 4, learning target 5, predicting reaction products, N. So my suggestion again is to practice some of these. Know, of course, which ones they are. And he does it a little differently than I did. I'm trying to give you a little more information, but if you click on one of these, for example, like this one, let's open it up real quick. And, okay, yeah. Okay, so here he doesn't actually tell you what the reaction is either. So that's going to make it even harder. So I'm telling you what it is. But you might guess, looking at the second one, hey, I've only got one reactant. Where is that going to fall into those types of reactions? This is going to be our decomposition. So we're going to get two products. So we're going to get a product that's Ag, silver, and a product that's sulfur. And then you'll want to balance it, and that one's not too bad. But the other ones that are a little more problematic are the double displacements, like this one here. This one is double displacement, and it's also a neutralization because you've got hydrogen ions and hydroxide ions. Those are going to combine to form H2O, water. So, I'm going to try to, kind of not make this too difficult for you guys, but really what I'm trying to say is you got to practice. And before you even practice, make sure you get learning targets 1 through 4 down. So I guess after all, I'm going to stop there with learning target 5, because that second part of predicting the products is just a matter of practice. So, all right, one more target to go here.